Today we're going to be looking at zero product property, ZPP. So now we're going to be moving from linear functions to linear equations, and here is one of the property we need to know. So each of the following equations, the variables represent real numbers. Variables meaning x, z, q, l, m, n, o, p. Assuming each equation is true, what can you conclude about the values of the variable, the x, y, z, whatever? Explain each step in your reasoning. So how we're going to explain each step in our reasoning is solve it out, and we're going to show what's happening. So for the first one here, I want this equation to be true, meaning I need to know what the heck this z equals. Well, in order to do that, I need to get 2z by itself, meaning I need to get everything onto the other side that doesn't involve a z. So I need to get rid of this positive 3. The opposite would be to subtract it to both sides, because these are going to cancel, leaving me with 2z. Equals 0 minus 3 is negative 3. And z is still not by itself because it's attached to this 2. Well, since they're next to each other, their multiplication, the opposite would be to divide both sides by 2. So that way these cancel, and I'm left with z equals negative 3 over 2, or you can say negative 1.5. So now we've concluded that it's true because we've shown what z equals. So now I'm going to do the same thing with this one right here. 7z equals 0. Well, what times 7 would give me 0? Well, if I divide both sides by 7, I can see that x needs to be 0. Because 0 times 7 would give me 0. Alright, so then we're going to look at this one here. Remember, you need to distribute first. 7 times x is going to give me 7x. And 7 times a negative 5 is going to give me negative 35. Bring down my 0. Remember, we need to do the same steps as the first one here. Get 7x by itself by adding 35 to both sides. These cancel. I'm left with 7x. And again, divide by 7. Oh, hey, look! X needs to be equal to what? 5. Interesting. Because if we plug it back in, we have, let me zoom down a little bit. If I plug this 5 back in, I essentially have 5 minus 5 equals 0. Well, this would be 0 times 7, which would give me a 0. Alright, for this last one, now it doesn't have any letter at all. Or sorry, any number at all. It just has A and B. So for this, A could equal 0 or B could equal 0. Basically, either one of them has to be 0 in order for the final answer to be equal to 0. Okay, so it's kind of a review type thing here, figuring out what x or z or the variable equals. Now let's actually look at the zero property. So a zero product property states that if one product of the two numbers is 0, then at least one of the numbers is 0. So saying a times b equals 0, either a needs to be 0 or b needs to be equal to 0, just like what we were saying for the last one. Then we can use the property, we can use this property when we solve equations where the product is equal to 0. Meaning when I have a problem and it's equal to 0, I'm going to use the zero product property. Interesting. So for each equation below, use the ZPP to find all the solutions. So when we're looking at this first one here, okay, either the x on the outside here can be equal to 0, or the parentheses option here needs to be equal to 0. So let's see. If I have, I'm going to break these apart into the equation. So instead of being x times parentheses 3 minus 4x equals 0, I'm actually going to set these both separate equal to 0. Meaning this x is going to be equal to 0, so that would be one of my options. And the second part right here, this would be equal to 0. So 13 minus 4x equals, oops, I don't know why I put a slash through that, but that's okay, equals 0. So both of those need to be equal to 0. We obviously found the one solution here, x can equal 0. But let's figure out what x could also be equal to. So I'm going to solve this one-step equation by subtracting 13 to both sides. Those would cancel out. I have negative 4x equals negative 13. So now I need to get x by itself, and what I'm going to do is divide by negative 4 because that's what's attached to my x. Well, two negatives equal a positive, so my other option for x is going to be 13 over 4. Essentially, we're finding all the solutions that x could be equal to. So now I'm going to do the exact same thing with this 7 over here. I'm going to set, and I usually draw a line between the equation. I'm going to have 7 equals 0, because I'm going to have 7 set equal to 0 to see if I can make that equal to 0, which obviously I can't. 7 can't equal 0, so that's not an option or true. Meaning now this x plus 12, let me use a different color. This x plus 12 has to be the option that's equal to, that's going to be my option to make it equal to 0. So if I want x by itself, I subtract 12, and my actual answer is, in order to get 0, I have to have x equals negative 12. Where in the first option, my x could equal 0, or it could be equal to 13 over 4. Let's try two more examples here. Now this one's a little bit easier to see. I can actually split this up. I have x minus 19 equals 0, and I have x plus 3 equals 0. If I solve for both of these equations, my two options for x are going to be x equals negative 3 can be an option, or x and 19, positive 19. So I have a negative 3 and a negative 19 for those options. Sweet. So let's break apart this here, and we're going to set both of these equal to 0. Again, the reason why is to see what z could be or what x could be any of those options. Because I want to know if there's two options, because there could be. So in this case, if I add 6, because the opposite of a negative 6 is a positive 6, one of my z's could be equaled, or sorry, could be a positive 6. Or let's see what else it could be. Well, I need to get rid of this negative 4 by adding 4. So I have 3z. I'll change it a different color so you can see the difference. So now I need to divide by 3 to get z by itself. So my other option for z could be 4 over 3. Those would be my two answers. Or if you prefer, 1 1/3, however you'd like to write it. So those are the values for this. So now what we're going to do is we've been looking at it in just factored form. Now we're going to look at it in our standard form and turning it into factored form. So sometimes we can take advantage of this property to help us find the solutions to the equations. So we're going to do the exact same process that we've been doing. So first what I'm going to do is, I'm going to factor these out. So I know the factors of 15 are 15 and 1. I know it's 3 and 5, and I think that's it. So I know that this right here is a positive 15, and this is a negative 8, meaning that both of my numbers in here need to be negative. Well, let's see. if I have negative 15 and a negative 1, that's going to be negative 16. If I have a negative 3 and a negative 5, that's going to give me my negative 8. So I have negative 5 and negative 3. So if I split these both up and set them equal to 0, because I need to figure out what x could possibly be, I can see that if I add 5 to both sides, one of my options is x is equal to 5. So that's one of my options. And if I set this one equal to 0, I can see my other x option is a positive 3. In order to make this equation equal to 0, I either need to enter x is 5 or x is 3. Any other number cannot be. Alright, so now we're going to do the same thing to this one. But, this 7x is on this side. I actually need to move it over here because I want this to be equal to 0. So what I'm doing is I'm getting rid of this 7x by subtracting it to both sides. Now remember, this is a regular x, this isn't an x squared. So we're not going to combine it with anything. All I'm going to have is our equation here. And now I can solve it. Now I can factor it first. So if I factor this, I know the factors of 10 are 5 and 2, 10 and 1, and that's it. I can see that it's a positive 10 and there's a negative 7, meaning my numbers need to be negatives. So let's see. Negative 10 minus 1 would give me a negative 11. Negative 5 and a negative 2, hey, would give me that negative 7. So I have negative 5 and negative 2. Again, set them both equal to 0, and what we can see is, move this over here a little bit. What I can see is I have x minus 5 is equal to 0, because remember we want to set both of these to equal to 0 to see what my factors can be. So I would get a positive 5 for this problem, and if I had if I solved the other x minus 2, I know it would be a positive 2. So this option has positive 5 and positive 2. Let's try another one here. Oh, look at this. So I need to do the same thing. I want to set this equal to 0, meaning I need to get rid of my 6x. So now I have my equation x squared minus 6x equals 0. So in this case, I don't have any number after, meaning I can't multiply. So there's no C option. So like back here we had 10 as our C, we don't have a 10. So what we can actually do, we can actually factor this. Both of these have something in common. They both have an x. So I'm actually going to take an x out of both of these. And what's going to happen is I'm going to have x minus 6. So if I distribute this, I get x squared and x minus 6. Now I can factor it. Or sorry, set these both equal to 0. So I'm going to set x equal to 0, which is one of my options. And then I'm going to have x minus 6 set equal to 0. Because remember, I need to figure out both options. So both of my two options that x can be is 0 and 6. So we're going to have to come back for this last part maybe. So I'll start this one out. What you would do is you would distribute. So you distribute that 2x to everything in that parentheses. You would combine any like terms. You would then factor it out. Then you would set both of those factors equal to 0, and then solve for x. And your final answers x could be is -3/2 or a +1.